Good day, everyone. I am Miss Hanami Sampit, BSE Science 3, and today we will solve the problems on photoelectricity. First problem is VP38.3.1. A laser emits 2.13 times 10 to the power of 16 photons per second, each of which has wavelength 625 nanometer. Find the energy and momentum of a single photon and B, the power output of the laser. In here, we will use IC method, identify. This problem involves the energy and momentum of a photon. Setup. So in here, we will use this formula. In the execute part, we want the energy and momentum of a photon. So we arrive at the answer of 1.06 times 10 to the power of negative 27 kilogram times meter per second. And in letter B, we want the power output of the laser. So we arrive at the answer of 6.77 MW. In the evaluate part, don't confuse the frequency of the light with the frequency at which photons are emitted. They are very different. So our final answer is in letter A is equal to 3.18 times 10 to the power of negative 19 joules. P equals 1.06 times 10 to the power of negative 27 kilogram meter per second. And in letter B, 6.67 times 10 to the power of negative 3 W. The second problem is VP38.3.2. A certain metal has a work function of 4.55 eV. For this metal, find the minimum frequency that light must have to produce photoelectrons with the maximum kinetic energy 1.53 eV. So in the IC method, identify. This problem is all about the photoelectric effect. So in the setup part, we will use this formula. In the execute part, letter A, we want the minimum frequency to produce photoelectrons. This is the threshold frequency at which the kinetic energy is zero. So we arrive at the answer of 1.10 times 10 to the power of 15 Hertz or Hz. In letter B, we want the frequency when the maximum kinetic energy is 1.53 eV. So we arrive at the answer of 1.47 times 10 to the power of 15 Hertz. In the evaluate part, be prepared to use H in units of either GS or EVS depending on the given units so that we can avoid tedious unit conversions. So our final answer in letter A is 1.10 times 10 to the power of 15 Hertz, and in letter B, 1.47 times 10 to the power of 15. Third problem is VP38 3.3. In a photoelectric effect experiment, the stopping potential is 1.37 volts. If the light used to illuminate the cathode has wavelength 475 nanometer, find the work function in EV of the cathode material and the stopping potential if the wavelength is decreased to 425 nanometers. So in the IC method, identify. This problem is all about photoelectric effect. In the setup part, we will use this formula. Execute part, we want the work function, so we arrive at the answer of 1.24 eV. In letter B, we want VE if lambda is equal to 425 nanometers. So we arrive at the answer of 1.68 eV. So in the evaluate part, decreasing the photon wavelength increases its energy. So the stopping potential increases. So our final answer for this problem is in letter A 1.24 eV and in letter B 1.68 eV. Last problem, VP38.3.4. Your results from a photoelectric effect experiment show that the maximum speed of the emitted photoelectrons is 6.95 times 10 to the power of 5 meters per second. When the cathode is illuminated with ultraviolet light of wavelength 306 nanometer, find the maximum photoelectron kinetic energy in EV and the photo energy in EV and the work function. In the IC method, this problem is about the photoelectric effect. In the setup part, we will use this formula. Execute. Letter A. We want the kinetic energy in EV. So we arrive at the answer of 1.37 EV. And in letter B, we want the photon energy. So we arrive at the answer of 4.05 EV. In letter C, we want 0. So We arrive at the answer of 2.68 EVs. In the evaluate part, the work function is about the same as for sodium. So our answer is reasonable. Our final answer is in letter A 1.37 EV, and in letter B 4.05 EV, and in letter C 2.68 EV. All, thank you for watching.